All right, welcome. My name is Mr. Fincher, and this is the online version of your lesson for today. So to start out, I would like for you to take out a sheet of paper, draw a big circle with an X and a Y axis, and go back to the memory you had of the unit circle, complete with degrees, radians, and coordinate points. It should take you about 5 minutes, so please pause this video. Yes, right now, pause this video and get started. Okay, now that you have created your unit circle, you can check and make sure that it matches what you see here. All of your signs, all of your values, all of your radian and your degrees. All right, so for today, we have a couple different objectives. The first objective that we're going to talk about is completing the connection between what we call a polar coordinate and a rectangular coordinate. All right, so you see polar, there's little Olaf being cool. You might not know much other than polar as far as temperature goes, but we'll talk specifically about that in our lesson today. All right, so let's go ahead and get started. So we're going to consider the point 3, 3. Let's go ahead and graph that. I'm going to graph it over here on the left, actually right above this really cool, oh, that's red. That's not what I want. This really cool astronaut. We're going to graph 1, 2, 3, 1, 2, 3, and put a dot right here. Okay, so we have two questions that we think of when we actually make a coordinate into polar. The first question on the left says, how far is the point from the origin? Well, that's kind of this line right here. And if we were to connect these three, we'd say, okay, that's 3, and we can use the Pythagorean theorem. So we say 3 squared plus 3 squared square rooted would be this value. And just because we're talking unit circle today, let's call that r, or a radius. You know, our radius for the unit circle goes from the center, from the origin out. So let's just do that. All right. So that means that we have 9 plus 9, which is 18, which I think we can simplify. That's divisible by a perfect square of 9. So we can say that that's 3 root 2. Okay. So that is the first part that we need to think of when we are trying to change a coordinate from our regular rectangular coordinate to a polar coordinate. So what angles does it make with a positive x-axis? Well, here's our positive x-axis. I'm going to highlight that over here. Let's highlight that here. That's our positive x-axis. And we're trying to figure out what is this angle right here. Well, nice thing about 3 and 3 is that that makes a 45-degree angle or a pi over 4 angle. So we can name it two different ways. We can, if it was in degrees, we could say it'd be 45 degrees, or we could call it pi over 4 because pi is all the way to here, so it's a fourth of that. Okay, so those are the two questions that you can ask yourself if you're going from rectangular coordinates to polar coordinates. Now, how is it set up? Let's check it out. For polar coordinates, you will write up here at the very top, you can notice that we have r and we have theta. Okay? R is our radius that we just discussed in the last slide, and theta is the angle. So let's jump into our first question. It says for us to find the polar coordinate of 5, negative 9. All right, so we're going to be able to think through where is this? This is on let's see, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's in the fourth quadrant. We also know that it is, it has some kind of length that we're going to look for first for our r. So if you remember from vectors, we actually found the magnitude, and this is very similar formula, just different values, and then it's represented as r. So let's check and see what that is. So r is going to be equal to x squared, which is 5 squared, plus negative 9 squared. So that is equal to 25 plus, that would be 81. Okay. Now that we have 81, we're going to add those two together. That would be 106. Now we got to think through, does that divide by anything aside from just 2 or 4? Maybe it divides by 4. Let's see what would happen if we divided by 4. So that would be 4. If we half 106, that's 53, and I don't think that divides again. So I think we're good to stay at 106. We'll see in just a little bit if that is correct. Okay, so now we have our angle. And our angle, we have a formula up here. We're going to use our calculator for this one because this is not something that we can find on our calculator. Or excuse me, not on our calculator, on our unit circle. So tan inverse, because if we're looking at this, we're going to try to find this angle here. So tan inverse is going to give us a yx. So tan inverse for us right here would be negative 9 over 7. Excuse me, 5. Okay. And let me get my calculator and see what we get. Hold on. All right, so in my calculator, I'm pressing the second button and the tangent button. I'm also going to make sure I'm either in degrees or radians. Let's go into degrees for right now. And then we're going to go tan inverse of negative 9 divided by 5. And we get negative 60.94. Now, if we're looking at that, we're in the fourth quadrant. So that means that that's a correct angle for this. But we might want all the way around here. So we're going to take that value and add 360 to get a positive value. So the way we would write our final answer is going to be root 106 to 99.05. All right, and for right now, let's do 2 decimal places throughout. On any assessments, you'll be told which ones you're going to go for. Okay, let's move to our second example. S is given as negative 3, 4. So let's go ahead and put a dot where that belongs, negative 3, negative 4. Remember, this is called rectangular because we create a nice rectangle here. And our radius is from here to here. So we can go ahead and find that. R is equal to the square root of negative 3 squared plus negative 4 squared. So R equals 9 plus 16. R equals square root of 25, which is, and we'll do the composite of it, which is 5. Now we're going to use our calculator to find out what tan inverse of negative 4 over negative 3 is. Second tan, negative 4 divided by negative 3. Press enter, we get 53. Now that is definitely not 53 all the way around from here to here. So as you can see, that's the reference angle that we discussed in our trig lesson. So we're going to add 180 to that to get the actual angle. So we end up with 5, 233.13 degrees. Should probably put degrees over here. All right, we can also find both of these in radians, but for right now we're sticking with degrees because we're told what to do up here depending on the quadrant. In the first quadrant, it's the exact value because our reference angle is the same. All right, let's move along. We're going to find the polar coordinates of these guys. Now these look a little bit more friendly because they have square roots. I know you might be scared, but it's not a big deal. Let's go ahead and see what would happen if we find the radius of this guy. So I know that radius is equal to the square root of 3 squared plus square root of 3 squared. We're going to finish this up in just a moment. So we'll come back with just this.